Record. Right. So this one I'll go briefly through the physical layer. I think from chapter 3 you got introduced to different layers, the network, specifically the 7 layers, the OSI model. And I recommended to understand the network. I think that's the starting point because you have those 7 layers and how they function. Each layer, how does it relate to the layer above it, to the layer below it? So this chapter specifically focuses on the physical layer, which is the first layer of the OSI model, or the last, depending on what you're talking about. Right. Kana uri kusenda message tichitangira kumusoro the application layer tichidzika neprocess inonzi encapsulation. Physical layer rinenge riri the 7th layer, but kana tiri kuita process de-encapsulation rinenge riri the first layer. So basically what you learn, screen rangu riri kuoneka ni?
Yes.
All right.
Yes.
We'll discuss purpose of the physical layer, the characteristics, the types of my connections that now from the wired to the wireless. Wired up to the copper cabling, UTP, which is copper as well. We have fiber, then we have wireless. The physical layer basically door connection here between two my devices. How are we sending information from one device to the other? What is the medium? I think that's the biggest component here, physical layer. What is the medium? Chi will connect the 2 points that will send information. So if I'm sending information from this PC via Zoom, what is in between my PC and your phone or your PC? That's the medium. So you can see the depending wireless at some point, depending wire, depending fiber at some point, depending on what connect, say, your device to the network. That's how the physical layer, the medium differs. So, right, let me try to follow this way freestyle. Let me try to follow Jerimomu Manos Enyu. So just briefly going through the physical connection. Right. So basically up and the physical layer is mostly concerned with the physical connection. What is connecting the two devices that are communicating with each other, right? So you see we have the medium, which can be wired, which can be wireless. Then I think most importantly, TNE runs NIC, the network interface card. My laptops, they have that, what we call the network interface card. Ndo pano point, connect to the network yedu, right? The physical connection. The physical layer, we have a process of encapsulation, adding my data, my headers, my trailers, by information here, by the top of the OSI model application, iri data, yodzika, yoita segment, yoiswa my headers, pa transport layer, yodzika, yoiswa pa layer 3, pa network layer, yodzika, yoiswa the frame, then yapedza, yovasvika to the physical layer. The process here, it will explain what encapsulation. And the physical layer and open a last step encapsulation here. So encapsulation is appear. We can see from this diagram. I think I can do something like this. Point variable. Right. So we can see encapsulation is appear. Now the physical layer takes over. So this connection is the physical layer describes Rubitica with this connection in up at the medium. It also describes what is being used to connect to this device or this device, which is the NIC that I've already discussed. Right. Next slide. The characteristics of the physical layer. We have my standards. Chapter 3 introduces us to my standards and protocols. Standards, for us to communicate, we need to have modes of communication that is standardized. Why? So that everyone conform to the standards. Customer standards, muna communication. Pane muna ne reverb apa, monitor yourselves, pane noise. Kana tisina standards, communication here, it is not being guided. So with the standards comes communication which is guided, which is uniform. We have what we call interoperability, where different devices from different vendors can communicate. This is because of standards. I think it was introduced in chapter 3. So my standards are able in each layer. Standards and protocols, I think sometimes they can be used interchangeably, those two terms. There are standards in the application layer, presentation, up until the physical. And we're going to look at some of the standards that are more physical layer. My organizations who are responsible for those standards in Dwarapa, most notably IEEE. As an engineer, I think you will not be able to escape IEEE because I think it is responsible, this organization is responsible for most of the standards that we use in communication. Bluetooth, your Wi-Fi's, most of your wireless communication is defined as a standard by IEEE. Right. The components of the physical layer, we have the physical components, which are the physical devices. So the physical devices, the root communicator, they are part of the physical layer itself. You see, I think you see pacheta the troubleshooting. How do you find a problem in a network? We always say troubleshooting here, do we troubleshoot using my layers? In Cameroon physical layer, you'll be checking with the one device yangu kushandere. Is it operational? It on it. Let's say communication is attribute upon suddenly connection is off. We can no longer communicate. From the physical layer perspective, you check with laptop because that is a component of the physical layer. Laptop can a laptop on, laptop at the other side it on it. Yes, it on. Step number one, but we start looking at the cabling. For example, can I reconnect it to the LAN? I'm connected wirelessly. If I'm connected to the LAN, then I check it, my cables are connected here. Those are components of the physical layer that will check up at troubleshooting. Can I add wireless data on it, the mobile data on it? You understand? So those are some of the data is per physical, but the physical cabling, the physical devices, then my intermediate devices here, the switch ready operational area, router ready operational area, can't out of some network. That's the physical components of the physical layer. We also have my standards are not defined encoding here, how data is being sent so that it is understood on the other side. On the receiving end, your communication end, we have the transmission, we have the receiving end, encoding at one end, decoding at one end. So we have standards which define the encoding chi. I think we have examples, the encoding, we'll look at it. We also have signaling. How is information being transmitted? So can I chance a wireless network? We'll see probably we're using electromagnetic waves or microwaves to transmit our information. Can I chance copper? And then chance my voltages to transmit my message. If I'm using fiber, I'll be using light to transmit my message. So different media, different signaling, different standards to define that. Right. Then we have encoding. Conveys a stream of bits into a format recognizable by the next device in the network. How is it recognizable by the next device? It's just a process of encoding and decoding. And I'm Mike, to say a process bits up. How do we get to these bits? All right, how do you get to to this piece. Patakaita number systems, patakatanga introduction of digital systems. What is the digital signal? A signal defined by discrete points, 1 zeros, 1 zeros. Ndipo makatengera po communication yenyu. From there, it will lead to what we call encoding. It's sort of a language. Language, encoding, decoding, kunzwisisa language. Do you understand that language? So when you send the information, most of the times, the decoder needs to know what language are you speaking. And what language you are speaking, it can be these 1 0 1 zeros. It can be this type of codes that require Manchester. I think we also have my English codes. There are a couple of codes in Shanscopa encoding. I think I'm not going to go deep into encoding, but basically encoding it can mean the physical layer, and chi is just a language. Shandiswa devices edu. The other side, the receiving end, should know what is the language being spoke by the sending device. Do you know decoding? If the language is then we can communicate. Encoding and decoding. Right, to end up signaling methods will be varied on the type of medium. Right, signaling is basically how the information is being transmitted. After encoding, we have a process that's not modulation. You won't escape that one. Telecommunications modulation, where information encoded by here, it is sort of being joined by another information. Can I do with my frequencies like this one? It is joined by another signal, high frequency. Then it is used to transport the information going to the other end. So in this, in a high frequency, I think some voltages for this specific one. Then it get a modulation here doing light. Can I true fiber? If we want to send our information via the fiber medium, then we modulate information here at an encoder using light. Light is then used as a vehicle to transmit your message. Right? You learn that my messages they have very low frequencies. And what happens when low frequencies travel my distances, they get attenuated. The reason why you won't be able to hear me that other side without microphone, without my message being modulated with the high frequency. It's because it gets attenuated. Now we need to have a high frequency signal and not transmit information here. So in this case, high frequency signal radio and all light here we have a voltage in a high frequency. My electrical signals, I think those the same voltage. No, here we have microwave. When we are using the wireless media, when we are using the copper media, and when we are using the fiber. And basically that is signaling. So my standards which define which type of signaling we use, they're defined in the physical layer. Then we have that term bandwidth. Bandwidth by definition is carrying capacity medium. I give an example here. Lorry. If you have a 3-ton truck, it means it is able to carry 3 tons. So guys are 2 tons, it can manage. Guys are 1.5, it can manage. But you guys are 6 tons on a 3-ton carrying truck, that's overload. It won't be able to manage a family. So it's the same thing with the networks. If we have a bandwidth, your network here, the router bandwidth is 1 gigabyte per second. 1 gigabyte per second. If you try to push information in more than 1 gigabyte per second, what happens? And the answer, what happens if you try to push information in a more than 1 gigabyte per second? If you have a 3-ton truck and you try to load 5 tons, what happens? That's overload. Truck. The same happens when you're trying to push 3 gigabytes per second, 3 gigabytes per second on a medium in a 1 gigabytes per second bandwidth. Congestion, ndopamunoti network yedu iri kunetsa, network iri slow. Basically what is happening, there is too much traffic, but bandwidth yenyu shoma. So per usage, you see that most of the times on a Saturday, internet inenge inofamba zvisingaiti. Why? Because pane pasina traffic. Most of the students are not there. Bandwidth yedu yakakura. It can manage the small amount of people inenge iripo pa campus at the time. On a Monday, network inenge iri very slow because 3-ton track yedu yakuremerwa ne 5 tons dzevanhu dziri connected to the network. So that's the proper definition of bandwidth. Mune vanhu here muno?
Yes, sir.
Zoom unotaura wega. Right. So that's it for our bandwidth. To end up a cabling. So for my types of cabling yedu, we have copper cabling. Let me see. Copper cabling basically, copper I think is one of the most used type of medium atinayo. It used to be very efficient until fiber took over. Copper for short distances, it can be used very well. Long distances, suffer from what we call attenuation, loss of signal strength over distances. Right. That is it for our copper cabling. I think some of the things that are very important. Limit cable length, mitigation, attenuation, strict adherence to cable length limits. So it means kana uchishandisa copper, you don't have to use cables akareba stereo. That's why we see LAN cables edu 2 meters, 1 meter, 2 meters. Then kana standard which defines that copper cabling is a bit stronger. I think I'm gonna score 10, 20 meters, but you rarely see types of copper cabling, especially UTP, STP, and over 100 meters. It's because of attenuation, right? They also suffer from what we call EMI, electromagnetic interference. If we have electromagnetic, for example, even our phones, they emit some electromagnetic waves, our phones, the microwaves, my lights, I'm a fluorescent, they can affect the signal. Just because the light rakabatira, it can affect the signal of copper. So I think those are some of the disadvantages of copper. Then the crosstalk, I think it's another disadvantage. Running out of time, All right. Characteristics, types of copper cabling, we have UTP, STP, and shielded twisted pair. So in the LAN cable, atinoshandisa kana connected to the internet on your laptop, for example, it's basically this cable apa UTP, ndozayakangoita mukati. Then it has a connector, it's RJ45. Let me go to the connector. All right, this one. Ndo cable amunoshandisa to connect to the internet using a port Ethernet LAN, right? So basically, it's a twisted pair cable. I think next time we meet, talk on a session. I have to gather my cables. I got this one. So we have UTP, we have STP, we also have the coaxial cable. I rarely see this one being used, but I know the Shandiscope my satellite dish. If you have a satellite dish,
Yes.
if you have a satellite dish, Marine, I think this is the type of cable they use. Right, types of copper cabling, UTP. Right, so in preparation for your exam definitions. what defines it, not the UTP. Key, it's just a copper cable. What are the characteristics? What are the advantages? What are the disadvantages? Can you compare between UTP and STP? Can you compare between copper cabling and fiber cabling? Can you compare between wired connections and wireless connections? Those are some of the basics that you need to know to prepare for your exam. I'm just highlighting, just explaining. Vamwe vanhu kuverenga kunonetsa, but zvinhu zviri very simple zvomuye muchiverenga. UTP key characteristics, a twisted pair to protect the signal from interference. Why? Question ichatouya kuti why are those cables twisted? Say dziri kuya dziri twisted kudai. There's an issue, a crosstalk that eliminates not the crosstalk. A communication between is a sort of interference where the two wires dzinokwanisa signal iri kufamba neimwe wire inointerfere neiri kufamba neimwe wire. So with twisting is sort of cancelling that type of interference yatinoti crosstalk. Right, termination RJ45 yatinoti termination cable dzedu idzi hadzishande zvekuti unongobvisa tuwire auto-connected to the other network. We have tinoti connectors. It needs to be terminated with the connector. Zvekujoinidza wire nekudi in networking zvinokonzeresa, those are losses. They are losses, huge losses dzinoitika nekujoinidza wire. So instead of joining wire, sekusunganidza wire, tinoti proper termination. And in this case, toshandisa inonzi RJ45 connector to terminate our UTP. STP is sort of the bigger brother here, UTP. This one, inenge shield. I think it helps in reducing interferences. I can see panap. It provides AMI protection. So the other one I na shield. Right, the other one I na shield, but this STP, don't shield the twisted pair. It has a shield, but that comes with some disadvantages. It can be costly. Yes, it's effective, less loss, less EMI, less interference, but it is very costly. Very difficult to install as well. I think, like I said, UTP this is how you make an Ethernet an Ethernet cable, but your STP gonna go around one. So basically, difference between UTP and STP in a shield, right? Gender coaxial cable. Like I said, this one is rarely used these days. It is very expensive as well. So for my connections, it's like for my connections, I don't want to share this either the coaxial cable or the twisted pair cable. If both of them work perfectly fine with minimum attenuation, why choose cable very expensive? I think that's why coaxial cable to sort of move out of the market, because it's expensive and we have other options. The twisted pair instead of using coaxial. Right. Then we have 4 minutes UTP. I think I've opened a little bit deep to UTP chi, Tambutaranye, crosstalk. All right, let's talk about my standards. The standards AMA cables they're defined by the type of the cable length, the connectors, the termination, the cable termination, and the testing methods. What do we mean by that? You see for my cables and 4 wires. Let's see. Panapa in category 3, 5, and 6. What is the difference between these? Category 5, Ndoma standards. Category 3, Ndoma standards. You can see these cables, they are not twisted. That's why it's called category 3. It's a different standard to this one. This one, in wires are twisted. Then this one, in wires are twisted, and on top of it, panel a sort of shield garipa. That's another category, wires. Then, with respect to length, you see different lengths defines different standards. But of upper 10 meters, which in 20 meters, we're going to define a different standard. Cabling. So as an engineer, you also know for can I connect two my PCs in a local area network distance less than 5 meters? What type of cabling do I need? Is it efficient? Is it cheap? Transmit the information yangu pasina loss. Those are not for those. So we cannot use a cable category 6, for example, connected to my devices, my PCs are less than a meter away. Why? Category 6, yes, it's very efficient, less loss, but it is expensive at the same time. So don't understand category 3 or category 5. I think category 5 is the most used standard for my local area networks. So understanding what type of standard yakaita say cable length yakaita say in a twisted pair, low set yakaita say, we can understand that those things, then you can manage the answer which type of cabling can connect which type of devices are separated by what distance. All right, my connectors here do AUTP. We have the most common one, RJ45. We also have, let me see, above with RJ45 only. Okay, so we have our connector here, then we have our port. This connector here. We have 2 wires that will show you up. Tichagadzira macables aya. Vana vasingagone vanoenda cable iri pamusoro. Inenge ine malosses cable iyoyi because inonyatsoterminatwa zvakanaka. Then we have this one which is correctly terminated. Very few losses as compared to that one. I think there is a question on my exam. What is happening between these two cables? All right, less than a minute. Continue.
Continue.
All right, so join me after I think a minute because this session is going to end. I'm going to change accounts as well because I realized with the after 15 minutes, then most will join. So I'm going to change accounts. I'll send you a link on WhatsApp. This is my eyes.